This video is a series of examples of TEMA motion analysis in automobile crash test scenarios. Many of these are applicable also to airplane seat test applications. In this sled test, TEMA is measuring displacement, speed and acceleration. It is getting the scaling from two targets on the sled, and it is referencing the displacement from the coordinate system shown by the two red arrows. This is a similar test, but here we are concentrating on the neck angle in green and the motion of the dummy relative to the seat. Now we are going to measure the angle and motion of the components of a seatbelt system using the seatbelt mounting bolt as the point from which measurements are plotted. This is done by transferring the coordinate system from the bottom left-hand corner of the image, the default, to the seatbelt mounting bolt. In this case, we are measuring the valve motion relative to the engine block. We again have to transfer the coordinate system from the bottom left-hand corner of the image to the top of the engine block so as to stabilize the block for measurement purposes. Now we are plotting the outline of an expanding airbag by tracking the grayscale difference between the airbag and its background. This puts an outline around the bag, allowing us to measure area, circumference, and extreme positions. The next step is to do this on two bags on the same test rig with the same camera position, and to then superimpose the views to check conformity to a standard. Finally, using several cameras, we can plot the outline in 3 dimensions, thus enabling us to plot the volume as a function of time. As with the seatbelts, in any crash test we can superimpose the images of sequential tests of the same configuration, as well as plotting the actual data on the same graphs and spreadsheets. These next 3 tests demonstrate this capability. In this test we have put quadrant markers onto the tires, and we are able to monitor transitory compression. This test of a head impact on the windscreen takes advantage of the 6 degree of freedom capability with one camera. Having surveyed the rigid body, the head, using the quadrant targets, we can plot the position X, Y, Z and also the roll, pitch and yaw of the head as it moves in space. Now we have added the force of the impact obtained from a force transducer and plotted it along with the position data. Here we measure the motion of a vehicle in an off-road excursion in 3 dimensions using 2 cameras. Using relative orientation we do not need a survey, just a straight line distance between 2 points in the field of view. This test by George Washington University staff achieved an accuracy of about 1 inch using this method.